Good morning, students. Myself Balasep Devde, and I am going to teach you one of the interesting chapter of physics, and that is thermal properties of matter. Which chapter? Thermal properties of matter. So far in physics, you have studied mechanics. To study mechanics, only three physical quantities, namely length, mass, and time, they are sufficient to explain all the phenomena which are related with the mechanics. To study the thermal properties of matter, we require an additional physical quantity that is known as the temperature. If one knows these four physical quantities, then the thermal properties of matter, the phenomena which are related with heat, which are related with heat exchange, can be studied by knowing these four physical quantities: length, mass, and time. Now, let us see at a first what is thermal properties of matter. The phenomenon or properties having to do with temperature changes and heat exchanges are termed as thermal phenomenon or thermal properties. I will repeat: phenomenon, phenomenon or properties, phenomenon or properties having to do with having to do with temperature changes, having to do with temperature changes and heat exchanges, temperature changes and heat exchanges are termed as are termed as thermal phenomenon or thermal phenomenon or thermal properties or the thermal properties. So the phenomenon or the properties which are deal with the changes in temperature, which are deal with the heat exchanges, they are termed as the thermal phenomena. Now let us introduce two terms. One is heat and the another one is temperature. Is the heat and the temperature they are the same? No, there is difference. Now let us know the difference between heat and temperature by a simple example. Suppose I was having two pots, this one pot and this another pot. Now initially let us consider that the temperature of both these two pot is T1, and suppose the temperature of both these uh, pot which are containing water is T1 and which is equal to 10 degrees Celsius. Suppose these two pot they contain water. This is the water which is there in this pot. Suppose the 1 liter water is contained in first pot and 10 liter water is contained in the second pot. Now with the help of an burnel, suppose this is the burnel and heat is provided. This is another burnel and the heat is provided to the water in these two pots. There is exchange of heat between the surrounding to the pot. This is the surrounding, this burnel that provide heat to it, because this temperature of this burner is very high as compared to this temperature of this water, and so the heat is continuously exchanged, the heat is continuously absorbed by this water, and suppose after some time the temperature of this pot which contain water become 100 degrees Celsius, and this temperature of this water is become 50 degrees Celsius. Which temperature is greater? Definitely this pot, its temperature is greater than the temperature of this pot. Is the heat received by this pot A is greater than the heat which is received by the pot B? No. Although the temperature which is received by pot A is greater than the temperature of the pot B, the heat which is absorbed by the pot A is less than the heat which is absorbed by the pot B. Why? Because although its temperature is increased by 40 degrees Celsius, but the volume of water is 10 liter, and from this you knew that there is difference between heat and temperature. Now let us see the definition of heat and temperature one by one, so that you get something about this heat and temperature. First, see the definition of temperature. What is temperature? Temperature is something which is a measure of degree of hotness or coldness of a substance. What is this temperature? This temperature is a measure of degree of hotness or coldness of a substance. How hot that substance is, how cold that substance is, that is measured, that we know by knowing the temperature of that substance. So what is temperature? Temperature is a measure. Temperature is a measure of degree of hotness, degree of hotness or coldness, degree of hotness or coldness of a substance. That is temperature. That just measure the degree of hotness or the degree of coldness of that particular substance. This hotness, this coldness is measured with reference to some standard value. The measure of hotness, the measure of hotness or coldness of a substance, with reference with reference to some standard value. With reference to some standard value. We are familiar with the different scales. The famous scale of temperature is Celsius scale. Celsius scale. Then we are also know the Fahrenheit scale, and the universally accepted scale is the Kelvin scale. These are the three scales. These scales, they are calibrated by knowing two fixed points. One is the freezing point. One is the freezing point of water, and another one is the boiling point. Another one is the boiling point of water. According to this Celsius scale, the freezing point of water is at 0 degree Celsius. In Celsius scale, we measure the temperature in terms of degree Celsius. In Fahrenheit scale, we measure in terms of degree Fahrenheit, and in Kelvin scale, we measure the temperature in terms of degree Kelvin. In Celsius scale, the freezing point of water is at 0 degree Celsius, and the boiling point of water is at 100 degree Celsius. The difference between the freezing point and the boiling point is of 100 division, and these 100 divisions, they are equally divided into 100 equal parts, and one part among them is 1 degree Celsius. In Fahrenheit scale, the freezing point of water is at 32 degree Fahrenheit, and the boiling point of water is at 212 degree Fahrenheit. The difference between this boiling point and this freezing point is of 180 division. Now the scale is calibrated by dividing this 180 equal part, and one part is 1 degree Fahrenheit. In Kelvin scale, the freezing point is at 273.15 degree Kelvin, and the boiling point is at 373.15 degree Kelvin. The difference is 100 divisions. So one division is 1 degree Kelvin. This for this Kelvin scale, there is an absolute zero, but for this Celsius and for this Fahrenheit scale, there are no absolute zero, because it is possible to cool down the substance below 0 degree Celsius, below 32 degree Fahrenheit, but it's not possible to cool down the substance below 0 degree Kelvin. Below 0 degree Kelvin, it's not possible to cool down that substance. Now let us see one interesting phenomenon with the help of which one can correlate the different scale. Suppose we wish to convert a degree Celsius to degree Kelvin. Then this is the formula. With the help of this formula, you can convert the temperature from degree Celsius to degree Kelvin. Suppose, for example, we are having the temperature in degree Celsius equal to 10 degree Celsius. Tc is equal to 10 degree Celsius. Now let us just substitute this. Tc is equal to 10. Then you get the temperature in degree Fahrenheit. It is equal to 1.8 into 10 plus 32. It is equal to 18 plus 32 is equal to 50. So 10 degrees Celsius is equal to 50 degree Fahrenheit. This is the temperature. And now let us see what is heat. In the previous example, in this example, we have seen that heat is exchanged from this burner to this water. This heat is exchanged from the burner to water, means this burner is at very high temperature, from higher temperature to the lower temperature. Now let us see the definition of heat. What is heat? Now let us see the definition of heat. Heat is something. What is heat? Heat is something. Heat is something that is transferred. That is transferred from a body at higher temperature. In above example, from burner to a body at lower temperature. In that example, that water. So heat is something that is transferred from a body at higher temperature to a body at lower temperature.